What sample size should be used to estimate the proportion of orange Haribo bears if the margin of error is to be no more than 5 percentage points? Let alpha equal 0.10. So we'll be using the 90% confidence level. Well, I want to assume that I don't know anything else about this situation, so I have to use the the sample size formula that says I don't know anything about p hat. So p hat times q hat in that formula turns into a 0.25, a worst case scenario. Well, if you're watching these videos in order, you know what I'll do in the second part of the video where I actually use the value of p hat I used when I examined the number of orange bears in this bag, but for right now I'm going to pretend I don't know that, or I haven't seen that video. So I need something to plug in for z sub alpha over 2. I need something to plug in for the margin of error. Fortunately, I'm told both of the things I need to know up here. So 5 percentage points, the margin of error will be 0.05. Z sub alpha over 2 at the 90% confidence level is 1.645. Remembering that alpha is 1 minus alpha is the confidence level, and then times 0.25. This will give me a sample size. 1.645 squared times 0.25 divide by 0.05 squared. I get 270.6, which I'm going to round up to 271. No matter what thing followed that decimal place, because I never want to make the margin of error go up or the confidence level change, I'll always round up when I'm picking a sample size. Because that's one of the morals to doing statistics, that the more things that are in the sample, the better your data will be. So here we get n equal to 271. Okay, so now I want to remember that I actually did a pilot study. That in that previous video, I had a sample of 60 Haribo bears, and 13 of them were orange. I'm writing off screen. 60 total bears and 13 were orange, and that would make p hat 13 out of 60. Or about 0.217. All right, well, 1 minus that gives me q hat, and then I can rethink this formula, because now I have an estimate to use for p hat and q hat. Nothing else about the formula changes. But now I can use the 0.217 times 0.783 q hat. Ooh, I should write things down correctly though. This critical value 1.645. Same as above. All right. 1.645 squared times 0.217 times 0.783 divide by 0.05 squared. And this time we get 184 when I round to the nearest whole thing because, well, samples. But again, even if this had 183.1, I'd round that up to 184. All right, this is the power of having that pilot sample. I could actually get away with using less things in my sample. So depending on what I know, I could get different sample sizes. This spares me some expense in buying fewer bags of Haribo bears. In a more realistic situation, this could really save some time and money in data analysis with even a larger difference between those two values. But that's it for now.